today we're going to look at diodes. Now a diode is a semiconductor that restricts current in one direction and only allows current to flow in one direction. Now if we take a look at the top right, we can see the symbol for a diode. Now a diode is consisted of two sides. We have the anode side and we have the cathode side. Now the anode side is positive and the cathode side is negative. Now this comes into play when we put the diode in a circuit. So if we put the diode in a circuit to create our battery source, we have our battery, which is positive, in our negative terminal. And we're going to connect the diode in what's called the forward bias configuration. Forward bias, and we'll get into that here in a second. So we're going to create our diode in the forward bias configuration. Now what does forward bias mean? Well, forward bias means connecting the diode on the anode side, which is positive, to the positive side of the battery or to the voltage source, in the cathode side, which is negative, to the negative. So we're going to connect the positive to the positive and the negative to the negative. Now in this configuration, we're going to allow current to flow. And current conventionally is going to flow in this direction. So if we apply voltage to the battery, current is going to flow through this diode. Now why is that? So why is that? Well, whenever we increase voltage in the forward bias, increase voltage, we're going to decrease resistance. So this is for the forward bias configuration. Forward bias. So whenever we increase voltage, we're decreasing resistance in the actual diode. Increase voltage, decrease resistance. So let's take a look at the reverse bias. Reverse bias. So we're going to keep the circuit the same. We're just going to flip the diode 90 degrees. 90 degrees. And this is going to put it in the reverse bias configuration. All right. So let's go ahead and delete our diode. And let's input it in the 90 degree. So here we're going to do the arrow, the head. Again, our anode is going to be positive, cathode is going to be negative. So now if you notice, the positive terminal is connected to the negative terminal, and then the positive to the negative. So now we are in the reverse bias. Reverse bias configuration. Now what does this mean? Well, current is still going to flow in the same direction. It's still going to try to flow in this direction. However, this diode is now going to resist the current, and there will be zero current flowing back to the actual battery on the negative side. Now why does it do that? Well, when we increase voltage, so whenever we increase voltage, we're also increasing resistance. Increasing resistance. So in the reverse bias, it is limiting the current in the circuit. Whenever you increase voltage, you're increasing resistance.